This is Measurement Relationships 8.4, the surface area of a cone. Now, a cone is a very familiar object to many of us. We quite often have ice cream in some sort of waffle cone or some sort of other candy cone. So we're familiar with kind of that shape. And all a cone is an object that has a circular base, so like a round base, and then above it kind of comes to a point, and this is its vertex. Now, the surface area of a cone consists of the area of that circular base and something that's also known as the lateral area. So here, I kind of have a cutout of what would make a cone. A cone starts off as a circle, but then it has kind of a section cut out of it, and the two sides kind of come together. This kind of original kind of radius we call now the slant, or S. So this is like the slant length. So the slant length, moving on to here, is this length here, going from the vertex all the way to the base. The radius, which we're very familiar, is the radius of the bottom circle. So it goes from the center of the circle to one of the edges. So that's my R, or radius. So those are the only two kind of key pieces of information that we need. So we can make our own cone by taking a larger circle, cutting out a section like this, folding it around and attaching it so that it becomes more of a cone at one point, and then putting on a circular base. Let's take a look at an example of how to calculate surface area. So let's say I have this cone here. And this cone has a radius of 3 centimeters. It also has a height from the center to the vertex of 4 centimeters. So I want to find out the surface area, but I'm missing one key piece of information. I don't know what the slant height is. I don't know what the slant length is. But if you notice that between the height and the radius, I am forming a right-angled triangle. So using Pythagorean theorem, which we learned about in lesson 8.1, we can figure out what this slant height is. So Pythagorean theorem, I have my c squared is equal to a squared plus d squared. C in this case is actually my slant height squared. A is 4 squared. B is 3 squared. So S squared is equal to 16 plus 9. S squared is equal to 25. Square root both sides. So I have S is equal to 5. So my slant height is now 5. So once I have my slant height, I can just put it into my formula. And in my formula is for the surface area of a cone, pi r, so radius, times the slant height, plus pi r squared, which is the area of a circle. Pi 3.14 generally. R in this case is 3 centimeters. S is 5 centimeters. Plus pi, again 3.14. And 3 centimeters squared. So I get a total of 47.1, rounded of course, for the first section, plus 28.3, also centimeters squared, for a grand total of 75.4 centimeters cubed. Main thing to remember when we're looking at the surface area of a cone is that we have to know this slant height here, and we have to know the radius. Once we know those two key pieces of information, we're able to solve very easily for the surface area of a cone.